Okay, this is going to be a quick recap video where I'll go over some of the important ideas about how to solve a linear system by graphing or graphically. First of all, when I say solve the linear system, all I'm really saying is find out where two lines intersect, right? These are both equations of lines. You can tell that because I'm connecting x and y, so we know that we can draw this on the grid. The first equation, the first thing I'm always going to do is label the equation. So the first one is equation 1. Equation 1 should be pretty straightforward to graph because I'm already in y equals mx plus b form. So I know my y-intercept is 2, right? I know b is equal to 2. So I'm going to start at 0, 2. And then my slope is negative 1 over 2. So it's rise over run. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. I like to put in lots of points because that makes it easier to draw my line precisely. And we'll talk about why it's important to draw a really precise line in a minute. Equation 2, the second equation, might take a little bit more work. We could either use the intercept method, or I could just rearrange into y equals mx plus b form, whatever you're more comfortable with. So if I rearrange this, I'm going to move the x onto the other side. So positive x now becomes a negative x. I still have a positive 7. But I want positive y on the left-hand side. So I'm going to divide by negative 1. And I've got to do that to both sides of the equation to keep it the same. So negative divided by negative, so I've got positive y. Here I've got negative x divided by negative 1. That's just going to be positive x. And then positive 7 divided by negative 1 is negative 7. So I've rearranged this now into y equals mx plus b form, and let's label that as equation 2. It's helpful always to label, so it's really clear what you're doing on the graph. So here I've got a y-intercept or a starting point of negative 7. 1, 2, 3, 4, 5, 6, 7. And my slope, well, what's being multiplied by x? It must be 1. So I'm going to go up 1 because it's positive, and then over 1, up 1, over 1, up 1, over 1. And again, connect a smooth line. And it's really important to draw that line all the way through the grid because we don't know where we're going to find that intersection point. So in this case, our intersection point, which is our solution to the system, is at the point 1, 2, 3, 4, 5, 6, and negative 1. So remember, we've always got to have our x value first and then our y value. And as we've learned, we're always going to write any solution to a linear system by saying the POI, so the point of intersection, is 6, negative 1. So that's how we solve a linear system graphically. So you want to make sure that you graph both lines on the same grid and see where they meet. You may need to do a bit of work to get the line in a form that you're comfortable graphing. Now, let's say I want to check my answer or verify my answer with left side, right side checks. So what I need to do is 2 left side, right side checks. I need to first prove that this point, 6, negative 1, is on equation 1, and then I need to prove that it's also on equation 2. There's only one point that is going to be on both equations. So the left side of equation 1 was just y, and the right side was negative half x plus 2. So wherever I see y, I'm going to replace it with what I think y is. So I'm going to replace y with negative 1. And I'm going to replace x with what I think x is, which is 6. And then again, I'm going to simplify using bed math. What's negative a half times 6? Well, that's going to be negative 3 plus 2, which is negative 1. So sure enough, the point is on the first line. Okay, so I must have graphed it correctly. Awesome. That's not sufficient to verify that this is the point of the intersection. I've also now got to prove that the point is on line 2. And again, I'm going to start with the initial equation always given to me in the problem. And I'm going to split that into my left side, right side. So in this case, the right side of that second equation was 7, and my left side was x minus y. Okay, well, I think x is 6, and I think y was negative 1. Be careful with your negative signs. So 6 subtract negative 1 is the same as 6 plus 1, which is 7. My left side equals my right side. So the point is also on equation 2. So therefore, I knew that I was correct. The POI is 6, negative 1. So if I ask you to solve a linear system graphically and verify, this is what your solution should look like. I should have two labeled lines with arrows. I should have a POI statement, and then I need to have two left side, right side checks because I'm showing or verifying that this intersection point truly exists on the two lines. Okay, that's all for now. Shoot me an email if you have any questions about solving linear systems graphically.